All right, chapter 5. The rise of the equal hour. Bum, bum, bum. While man allowed his time to be parsed by the changing cycles of daylight, he remained a slave to the sun. To become the master of his time, to assimilate night into day, to slice his life into neat, usable portions, he had to find a way to mark off precise small portions, not only equal hours, but even minutes and seconds and parts of seconds. He would have to make a machine. It is surprising that machines to measure time were so long in coming. Not until the 14th century did Europeans devise mechanical timepieces. Until then, as we have seen, the measuring of time was left to the shadow clock, the water clock, the sand glass, and the miscellaneous candle clocks and scent clocks. While there was remarkable progress 5,000 years ago in measuring the year, and useful week clusters of days were long in use, the subdivided day was another matter. Only in modern times did we begin to live by the hour, much less by the minute. The first steps toward the mechanical instrument of time, the beginnings of the modern clock in Europe, came not from farmers or shepherds, nor from merchants or craftsmen, but from religious persons, anxious to perform promptly and regularly their duties to God. Monks needed to know the times for their appointed prayers. In Europe, the first mechanical clocks were designed not to show the time, but to sound it. The first true clocks were alarms. The first Western clockworks, which set us on the way to clockmaking, were weight-driven machines which struck a bell after a measured interval. 2 kinds of clocks were made for this purpose. Probably the earlier were small monastic alarms or chamber clocks called horologia excitatoria, or awakening clocks, for the cell of the custos horologiae, or guardian of the clock. These rang a small bell to alert a monk to summon the others to prayer. He would then go up and strike the large bell, usually set in a tower so that all could hear. About the same time, much larger turret clocks began to be made and placed in the towers, where they would ring the large bell automatically. These monastic clocks announced the canonical hours, the times of day prescribed by the church's canons or rules for devotion. The number of these hours varied, of course, with the changing canons of the church, with the varied customs from place to place, and with the rules of particular orders. In the 6th century, after St. Benedict, the canonical hours were standardized at 7. Distinct prayers were specified to be said at the first light or dawn, matins or lauds, with the sunrise, ora prima, at mid-morning, ora tertia, at noon, ora sexta or meridius, at mid-afternoon, ora nona, at sunset, vespers, or ora vesperalis, and at nightfall, compline or completorium. The number of strokes of the bell varied from 4 at sunrise to 1 at noon and back to 4 again at nightfall. The precise hour, by our modern calculation, for each of these prayers depended in any given place on the latitude and the season. Despite the complexity of the problem, monastic clocks were adjusted to vary the time between bells according to the season. Efforts to adapt earlier timekeeping devices to the making of the sounds had never been quite successful. A clever Parisian fitted a lens into a sundial to act as a burning glass, which precisely at noon focused on the touch hole of a small cannon, and so automatically saluted the sun at its apex. This elegant cannon clock, installed by the Duke of Orleans in the garden of the Palais Royal in 1786, is said to have fired the shot that started the French Revolution. Centuries before, complicated water clocks had been designed to mark passing time by tossing pebbles or blowing whistles. Some such devices were probably tried in monasteries. But a new kind of timepiece, a mechanical timepiece that was a true clock, would be much better adapted to the new mechanical needs. The very word clock bears the mark of its monastic origins. The Middle English clock came from the Middle Dutch word for bell and is a cognate of the German Glock, which means bell. Strictly speaking, in the beginning, a timepiece was not considered to be a clock unless it rang a bell. It was only later that it came to mean any device that measured passing time. These first mechanical clocks came into an age when sunlight circumscribed the times of life and movement, when artificial lights had not yet begun to confuse night with day. Medieval striking clocks remained silent during dark hours. After the 4 strokes which announced Compline, the prayers at nightfall, the next bell was not sounded until the time for matins. The prayers at dawn the next morning. But in the long run, the unintended consequence of the making of mechanical clocks and a hidden imperative of the machine itself was to incorporate both hours of darkness and hours of sunlight into a single equal-houred 24-hour day. The monastic clock, specially designed for sounding the time, pointed the way to a new way of thinking about time. The sundial, water clock, and hourglass were all designed primarily to show the passing time by the visible gradual flow of a shadow across a dial, or water from a bowl, or sand through a glass. But the mechanical clock, in its monastic origins, was made for a decisive mechanical act, a stroke of a hammer on a bell. The needs of mechanical timekeeping, the logic of the machine itself, imposed a new feeling. Instead of being synonymous with repeated cycles of the sun, which varied as the cycles of the seasons commanded, or with the shorter cycles of other flowing media, time now was to be measured by the staccato of a machine. Making a machine to sound the canonical hours required and achieved mechanical novelties which would be the foundation of clockmaking for centuries to come. The force that moved the arm that struck the bell was provided by falling weights. What made the machine truly novel was a device that prevented the free fall of the weights and interrupted their drop into regular intervals. The sundial had shown the uninterrupted movement of the sun's shadow, and the sand glass operated by the free falling of water or sand. What gave this machine a longer duration and measured off the units was a simple enough device which has remained almost uncelebrated in history. It was called an escapement, since it was a way of regulating the escape of the motive power into the clock, and it held revolutionary import for human experience. With the simplicity of the greatest inventions, the escapement was nothing more than an arrangement that would regularly interrupt the force of a falling weight. The interrupter was so designed that it would alternately check and then release the force of the weight on the moving machinery of the clock. This was the basic intervention that made all modern clocks possible. Now a weight falling only a short distance could keep a clock going for hours, as a regular downward pull of the falling weights was translated into the interrupted staccato movement of the clock's machinery. The earliest form was the verge escapement. An unknown mechanical genius first imagined a way of connecting the falling weight by intersecting cogged wheels to a vertical axle which carried a horizontal bar or verge with weights attached. These weights regulated the movement. When they were moved outward, the clock beat slower. When moved inward, the clock went faster. The back and forth movement of the bar, moved by the large falling weights, would alternately engage and disengage the cogs on the clock's machinery. These interrupted movements eventually measured off the minutes and later the seconds. When, in due course, clocks became common, people would think of time no longer as a flowing stream, but as the accumulation of discrete, measured moments. The sovereign time that governed the daily lives would no longer be the sunlight's smooth flowing, elastic cycles. Mechanized time would no longer flow. The tick-tock of the clock's escapement would become the voice of time. Such a machine plainly had nothing to do with the sun or the movements of the planets. Its own laws provide an endless series of uniform units. The accuracy of the clock, which meant the uniformity of its measured units, would depend on the precision and regularity of the escapement. The canonical hours, which had measured out the daylight into appropriate elastic units between divine services, were registered on clocks until about the 14th century. It was around 1330 that the hour became our modern hour, one of 24 equal parts of a day. The new day included the night. It was measured by the time between one noon and the next, or more precisely, what modern astronomers call mean solar time. For the first time in history, an hour took on precise year-round, everywhere meaning. There are few greater revolutions in human experience than this movement from the seasonal or temporary hour to the equal hour. Here was man's declaration of independence from the sun, new proof of his mastery over himself and his surroundings. Only later would it be revealed that he had accomplished this mastery by putting himself under the dominion of a machine with imperious demands all its own. The first clocks did not have dials or hands at all. They did not need them, since their use was simply to sound the hour. An illiterate populace that might have trouble reading a dial would not mistake the sound of bells. With the coming of the equal hour replacing the temporary or canonical hour, the sounding of hours was ideally adapted for measurement by a simple machine. Sun time was translated into clock time. By the 14th century in Europe, large turret clocks in the belfries of the churches and town halls were sounding the equal hours, heralding a new time consciousness. Church towers, built to salute God and to mark man's heavenward aspirations, now became clock towers. The torre became the campanile. As early as 1335, the campanile of the Chapel of the Blessed Virgin in Milan was admired by the chronicler Galvano della Fiamma for its wonderful clock with many bells. A very large hammer strikes one bell 24 times according to the number of the 24 hours of the day and night, so that at the first hour of the night it gives one sound, at the second, 2 strokes, at the third, 3, at the fourth, 4, and thus it distinguishes hour from hour, which is in the highest degree necessary for all conditions of men, unquote. Such equal hour clocks became common in the towns of Europe. Now serving the whole community, they were a new kind of public utility, offering a service each citizen could not afford to provide himself. People unwittingly recognized a new era when, noting the time of day or night, they said it was 9 o'clock, a time of the clock. When Shakespeare's character mentioned the time of the clock, they recalled the hour they had heard just struck. Imogen, Cymbeline's daughter, explains that a faithful lover is accustomed, quote, to weep twixt clock and clock for her beloved. While the populace now began to know the hour, several centuries passed before they could talk of minutes. During the whole 14th century, dials were seldom found on clocks, for the clock's function was still to sound the hours. They were not found on the Italian campaniles, although there may have been one on St. Paul's Cathedral, 1344, in London. Early dials were not like ours. Some showed hours only from 1 to Roman numeral 6, with hands that moved around the dial 4 times in 24 hours. Others, like the famous work of Giovanni de' Dondi, 1318 to 1389, enumerated the full 24 hours. It was not too difficult to improve clocks that had already struck the hour so that they could strike the quarter hour. A dial marked 1 to 4 was sometimes added to indicate the quarters. Later, these were replaced by the figures 15, 30, 45, and 60 to indicate minutes. There was still no minute hand. By 1500, the clock at Wells Cathedral in England was striking the quarter hours, but had no way to mark the minutes. To measure minutes, you still had to use a sand glass. Ooh, that was in 1500. A separate concentric minute hand, in addition to the hour hand, did not come into use until the pendulum was successfully applied to clocks. The pendulum also made it possible to indicate seconds. By 1670, it was not unusual for clocks to have a second hand, whose movements were controlled by a 39-inch pendulum with a period of just 1 second. More than any earlier invention, the mechanical clock began to incorporate the dark hours of night into the day. In order to show the right time at daybreak, this time machine had to be kept going continuously all night. When does a day begin? Answers to this question have been almost as numerous as those to the question of how many days should be in a week. Quote, "The evening and the morning were the first day," as we read in the first chapter of Genesis. The very first day, then, was really a night. Perhaps this was another way of describing the mystery of creation, leaving God to perform his miraculous handiwork in the dark. The Babylonians and the early Hindus calculated their day from sunrise. The Athenians, like the Jews, began their day at sunset and carried on the practice through the 19th century. Orthodox Muslims, literally following Holy Script, continue to begin their day at sunset, when they still set their clocks at 12. As we have seen for most of history, mankind did not think of day as a unit of 24 hours. Only with the invention and diffusion of the mechanical clock did this notion become common. The early Saxons divided their day into tides: morning tide, noon tide, and evening tide, and some of the earliest English sundials are so marked. Other widespread ways of dividing the day were much simpler than the system of temporary hours, which subdivided daylight and darkness. The 7 canonical hours marked the passing time for Columbus and his crew. Even after the arrival of the mechanical clock, the sun left its mark on the measuring of the hours. The double 12 system, by which Americans count the hours, is such a relic. When the daylight hours were measured off and subdivided in contrast to the hours of the night, the hours of each of the two parts were numbered separately, and so it remained, even after a machine required that time be measured continuously. The first 24-hour clocks, while substituting equal mechanical hours for the elastic, canonical, or temporary hours, still remained curiously tied to the sun. They normally used sunset as the end of the 24th hour. To ask how we came to our day, hour, minute, and second takes us deep into the archaeology of everyday life. Our English word day, no relation to the Latin dies, comes from an old Saxon word, to burn, which also meant the hot season or the warm time. Our hour comes from Latin and Greek words meaning season or time of day. It meant 1/12th part of the sunlight or the darkness. The temporary or seasonal hour, varying with season and latitude, long before it acquired its modern meaning of 1/24th part of the equinoctial day. Why the 24? Historians do not help much. The Egyptians did divide their day into 24 hours, temporary, of course. Apparently, they chose this number because they used a sexagesimal system of numbers based on multiples of 60, which had been developed by the Babylonians. This pushes the mystery back into earlier centuries, for we have no clear explanation of why the Babylonians built their arithmetic as they did. But their use of the number 60 seems to have had nothing to do with astronomy or the movement of heavenly bodies. We have seen how the Egyptians fixed 360 days as irregular days of the year, 12 months of 30 days each, supplemented by 5 additional days at the end of each year. They also marked off 360 degrees in a circle, perhaps by analogy to the yearly circuit of the sun, 60 being 1/6 of the 360, and so a natural subdivision of their sexagesimal system became a convenient subdivision of the circle, and also of each degree or each hour. Perhaps the Chaldean Babylonians, noticing 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, multiplied 12, the number of months, and a multiple of 6, by the planetary 5, and so arrived at the significant 60. An everyday relic of the primitive identification of the circuit of the sun with the full circle is our sign for a degree. The tiny circle we now use to designate a degree is probably a hieroglyphic for the sun. Ooh. If the degree sign was a picture of the sun, then 360 degrees, a full circle, would also properly mean a cycle of 360 days or a full year. The degree is as a way of dividing the circle was first applied by ancient Babylon and Egyptian astronomers to the circle of the zodiac to designate the stage or distance traveled by the sun each day, just as a sign described for them the astronomical space passed through in a month. Our minute, from the medieval Latin pars minuta prima, first minute or small part, originally described 1/60th of a unit in the Babylonian system of sexagesimal fractions. And second, from parte minutae secundae, was a further subdivision on the base of 60. Since the Babylonian arithmetic was based on that unit, it was their version of a decimal and was easier to handle in their scientific calculations than other vulgar fractions, minutiae, that would have been. Ptolemy used the 60-unit system for subdividing the circle, and he also used it to divide the day. Not until much later, perhaps in the 30th century, with the arrival of the mechanical clock, did the minute become the division of the hour. The language, again, is a clue to the needs and capacities of timekeeping machinery. The second was at first an abbreviation for second minute, and originally described the unit resulting from the second operation of sexagesimal subdivision. Long used for subdivisions of a circle, seconds were not applied to timekeeping until clockmaking was refined in the late 16th century. The clock did not entirely liberate itself from the sun, from the dictates of light and darkness. In Western Europe, the hours of the clock continued to be numbered from noon, when the sun was at the meridian, or from midnight, midway between the two noons. In most of Europe and in America, a new day still begins at midnight by the clock. The archaeology of our everyday life leads us all over the world. The 365 days of our year acknowledge our debt to ancient Egyptian priests, while the names of months, January, February, March, and the days of our 7-day week, Saturday, Sunday, Monday, remain our tie to the early Hebrews and to Greeks and Roman astrologers. When we mark each hour of our 24-hour day and designate the minutes after the hour, we are living, as a historian of ancient science reminds us, by the results of a Hellenistic modification of an Egyptian practice combined with Babylonian numerical procedures.